Professor Amit Kumar Patil from Department of Electronics and Communication Engineering, School of Engineering and Sciences, MIT Art Design and Technology, University Pune. Today we'll perform the experiment of the subject Digital Signal Processing Laboratory. The title of the experiment is to perform linear and circular convolution of discrete time sequences. So let us come to the experiment. First we will write the code for the linear convolution. Okay. So linear convolution, what is the MATLAB program? What is the MATLAB code? And simple, we have to put a MATLAB command conv x comma y. Okay. But here first we have to generate x function, then we will generate y function, and then we will write the MATLAB code. Okay. So we will take the input from the user. So let us generate the first signal. So here we have to write the command x equal to input. X equal to input. We have to take the input from the user. So between double inverted comma, enter the first sequence. Okay, enter the first sequence. So here by user we have to give the input. We can give any input like 1, 2, 3, 4, 5, 6, 7, 8, whatever of any value, any length, we can give the input. Okay. After this, what we want? We want that in one window we want all the three graphs. We want that our output should be like this. One window will open, and in this one window, first section will be of the signal x, second section of y, and third signal of z. Okay. So within one window we want three graphs. Okay. So command in which we can get all the three graphs in one window is subplot. What is the command? Subplot. Okay. Which type of window we want? We want that there should be one column and three rows. Okay, one column will be there and three rows. So dimensions we have to give three rows. So 3, one column, so comma 1, and at the first position we want the graph of x. So 3 comma 1 comma 1. Okay, this will be the command. 3 row, 1 column, and at the first position we want the graph. Okay, and now we want to plot the graph. So this we have taken as the discrete time signal. So what is the command? Command will be simply we have to write stem x. Okay, we have to write stem x. So it will plot the signal x. Okay. Now second signal, again we have to take the input from the user. Suppose the second signal is y. So what we have to write? Y equal to input within double inverted comma, enter the second sequence. Okay, enter the second sequence. Then again subplot. Okay, 3 row, 1 column, same window but at the second position. So here what we have to write? Comma 2. 3 row, 1 column, and at the second position. So 3 comma 1 comma 2. Okay, and then again we have to plot the graph. So what we have to write? Stem y. Okay, stem y. So it will generate the two signals. Okay, it will generate the two signals, and we want the third signal also. So third signal is the convolution of first and second. So command will be z equal to convolution conv x comma y. Okay, and then stem z. Okay, we will modify it further. Okay, but just we will return the short form of the code. Now I will run it. So if you run it, okay, it will ask to save. So it is experiment 2 from the DSP lab. Okay, so just save it, and here it will ask for the first sequence. So first sequence we will take like this: 1 comma 2 comma 3 comma 4. Then it will ask for the second sequence, so 5 comma 6 comma 7 comma 8. And here you can see first and second both sequence are plotted here. Okay, and also we want convolution of it. So here we will write the position, and also we have to write the position. So z equal to convolution x comma y. So write the position. So subplot 3 row comma 1 column comma third position. Okay. After this we have to write the stem command. 3 row, 1 column and third position. So now run it. So put the first sequence. I will close this previous graph. Okay. So 1 comma 2 comma 3 comma 4, then 5 comma 6 comma 7 comma 8, and now here you can see all the three signals are plotted. Okay, x, y and z. Okay, but what we will do here, we will give the labeling and title to each of the signal. So how we will give? Once x signal is generated, here we have to give the labeling to x and y axis. So for x, what is the command? X label. Okay, command is x label, and on x axis what we have taken? Number of samples. Okay, on x axis we have taken number of samples. Similarly, y label. On y axis what we have taken? Amplitude. Okay, and after this we have to give the title to the first signal. So command is title, and this is the graph for which? First sequence. Okay, similarly after this y signal is generated, second signal is generated, again we have to give the x label, y label and title. Okay, so what I will do here, from this I will copy it and I will paste it after this y. So x axis is same samples, y axis amplitude, title. This is what? Second sequence. So here I will put the second. Okay, and again after the final result that we have taken, calculated the convolution, again we will put the same things here. Okay, x label same amplitude, y label x label samples, y label amplitude, title is what now here? This is the final convolution. So here we will write the convolution of the two signals. Okay, so this thing we have to add to each graph, x label, y label and title. Now here we have to run the graph. So once we run the signal, it will ask for the first sequence. So 1 comma 2 comma 3 comma 4, second 5 6 7 8, either comma you can give or space you can give. Both options are available, comma or space, and then enter, and then here you can see now the proper graph, first sequence, second sequence and the final result of the convolution, samples, amplitude, convolution. So all values will be written. And for more clarity we can also add the grid lines. If suppose you want proper readability, so for each graph, after each graph you can also add the command grid on. Okay, it will give the proper clarity for the reading. So this was for the linear convolution. Now if you want to go for the circular convolution, so here we have to change the command. In place of conv, here we have to write cconv. Okay, cconv, and between x and y we have to take always the maximum value. So comma, I will write here capital N. Okay, comma capital N we have to write. Okay, z is equals to circular convolution x comma y comma capital. What is this capital N? What is capital N? Capital N is the maximum value between the length of x and y. So L1 comma L2. Okay, what is L1? L1 is length of x, and what is L2? L2 is length of y. Okay, so what we have done, convolution we have replaced by C, circular convolution. CONV x comma y comma capital N. What is capital N? Capital N is the maximum length between L1 and L2. If the sequence are of variable length, one sequence length is of 4, another sequence length is of 3. So always we have to take the maximum. So x comma y comma capital N is maximum between L1 and L2. L1 is what? L1 is length of x, L2 is length of y. Okay. So these modifications we have done. Now again I will click on here, run the program. Enter the first sequence. So 1, 2, 3, 4. Enter the second sequence 5, 6, 7, 8. Okay. And now here you can see the results. Okay. This is the circular convolution. Okay. Here in the title you can replace convolution by the circular convolution. So code will be similar, 3 to 4 lines we have to change in the circular convolution. Okay. So this is the proper way of writing the code. In command window we can do the practice. We can just type line by line and we can check the output. Once we know it, then we can type the full program in the script window. Okay. So this is entire about the experiment number 2, linear and